Good afternoon, everybody. My name is Christian Vincent. That's my pleasure to welcome all of you to this session this afternoon. As you know, we are FEops, and FEops is really engaged this year in the PCR, EuroPCR 2021. We have an education village, and today we will have a very interesting sessions on how to optimize the Watchman Flex in LEO preoperative planning using FEops HEARTguide. For that, this is my privilege and honor to have as a faculty Dr. Francesco Meucci, who is for Careggi University Hospital in Florence in Italy. So welcome, Francesco. It will be a Zoom meeting. It will be roughly for 30 minutes. The methodology is very clear. It will be a case-based discussion. We would like to be as interactive as possible because it's an education village. So do not hesitate to ask all the questions that you may have. For that, we have a chat line that you can see on your Zoom screen below. Please just put your question there. I will summarize those questions and asking those questions to Dr. Meucci at regular timing. The other way for having interaction together, we will also have some quick polls or questions. So please, if you can, just answer those questions. It will be very interesting to get a little bit about your opinion about what we'll be sharing. Just as a short introduction, I would like to say a few words about FEops. So FEops, it's a simulation computer evaluation for LEA intervention. And in this case, we are supporting the Watchman Flex device. So what we do, we make the acquisition of the CT scan from your patient. So it's a CT scan depending planning tool. So we make the acquisition of the CT scan. With this, we make the reconstruction of the anatomy. And with the acquisition of the device from Boston Scientific, we were making the acquisition of the Watchman Flex in this case. And with the interaction between the anatomy and the device, we can really observe with the FEops HEARTguide how the device will interact into a specific anatomy. In other words, all the images that you will see today are not overlay, but are really how the device is deforming into a specific anatomy. By saying that, I wish you a very nice presentation. I will stop sharing here and I leave the words to Dr. Meucci. Thank you.
Hi, Christian. Good afternoon to everybody, and thank you for this very kind invitation. I start sharing my screen now, just to let you see what are my cases. Sorry. I hope you can see my desktop. Please let me know if you see my slide.
Yes, we can see your slide, Francesco.
So I start with, sorry, these are my disclosures. And then this is my first slide. The title is introductory to the first case, is a mandatory ICE-guided left atrial appendage occlusion. And just before starting with the case, a quick poll, as Christian anticipated, now is being shared with you. The poll is about your planning strategy when you decide to close a left atrial appendage. So do you use a CT scan? Do you use an echo pre-imaging? Do you have the possibility of doing a 3D printing, or you just are the user of some kind of simulation? Please, if you vote, so we can have an idea, and then we will discuss about your answers. Then after the poll, I will show. My intention is to. I have prepared three cases, but then we will see if we have time enough for. So the audience is set on the basis of echo. So CT scan is 36% of our audience, and simulation is 18% of our audience. So let's go ahead, and then we will see together how the use of CT scan and the use of a simulation software like the one of FEops could be very useful in selected cases. And this is my first case. This was an 80-year-old male. As you can see, arterial hypertension, diabetes mellitus, and paroxysmal atrial fibrillation, with the most important point is the presence of a liver cirrhosis with portal hypertension and esophageal varices, so a clear contraindication to a transesophageal imaging, and a previous history also of repeated bleedings. So he was not treated with the anticoagulation, and he was referred to us for an occlusion of the appendage that we was planning with an ICE guide procedure. We are not a center doing many ICE guide procedures. We mainly use a transesophageal guiding. And in this case, we did a CT scan, and these are the common reconstruction we do from the CT scan with the measures of the landing zone, of the depth of the appendage. And this is in detail the landing zone. As you can read, the landing zone is around maximum diameter of 23.6, an average diameter of 21, and perimeter derived diameter of 21.5. So going inside the choice of the device, as you can read here in this sizing chart, we can decide in this case to implant 3 different Watchman Flex devices, because you can implant a 24, a 27, and even a 31. And this is, in my opinion, one of the beauty of this new Flex device, because you have the possibility of let's say, deciding a different device without being wrong, while before we was more, we had to be by necessity very much more precise. So you can go in the cath lab a little bit more relaxed about the choice of your final device. We will see together how the simulation could help in the choice of the device between those, let's say, 3 measures in this particular case. You can read the 10–30% of compression as the goal of our final implant. Sorry. Then this is the, so we did the CT scan, and we send the CT scan to FEops. And this is a video made by myself, and this is me playing, literally playing with the atrium and the appendage, just to see how is the morphology, and rotating all the atrium, how it becomes the implant projection, looking at the landing zone. As you can see, probably I stopped the video just to let you see better. There is a circle, a blue circle here. This is the landing zone. The FEops people is they became very good in finding the landing zone, and in the lower part of the screen you see the degrees of your screen, so you can predict very easily, moving the whole left atrium, your implant projection, in order to be perfectly perpendicular to your landing zone when you go in the cath lab and want to implant the device. And letting the video run, the other thing I do just to have the first impression is to go like a 90-degree with this little man, and to understand perfectly how much anterior or posterior is the direction of the main axis of the appendage. So this is my first scroll with this reconstruction by FEops, and I've done nothing about simulation. Now, in the second slide, this is what I do when I want to simulate. They prepared the devices as I suggested when I sent the CT scan, so 24, 27, 31 on the basis of the sizing chart. And also, if you are not experienced in this device, you can see that the morphologies looks better or worse, just as a first impression. So playing it again, just to see, sorry, together, you can see that the 24 probably it is a little bit small and doesn't fit very well all the ostium of the appendage. The 27, if I have to do a comment, proximally positioned, is a little bit prolapsing. The 27 distal is maybe the best position and the best device. 31 is definitely too big because it's prolapsing a little bit much inside the left atrium. And this is, again, a first look and the first impression. Then you can do another very useful measure, that is the degree of frame deformation. So this is another tool provided by the company, and you can select again the devices, so 24, 27, etc., and read here on this part of the screen the measure, predicted measure of the device once you have implanted. So you have the measure of the device, you have the prediction of how much will be compressed, and you can calculate, literally calculate the degree of compression before going in the cath lab. And you have seen all the devices. Now I let you see the measures in a more detailed way. So if I implant a device 24 millimeter proximally, I obtain a 22 by 2 according to FEops maximum diameter, and so an 8% of compression. If I implant the same device a little bit more distally, it is the same. The compression is always 8%, so it is not well compressed according to the sizing chart of the Watchman Flex. If I implant the 27, I have definitely a good compression. Also proximally, that is not my favorite deformation of the device, but it is 14%, so it is acceptable. If I implant 27 a little bit more inside, more distally, and I have room in this appendage to go a little bit more distally, the compression is 17%, so it is definitely good. The biggest device for this appendage, the 31, has a much more compression measure, so 22%. That is in the range of an acceptable compression, so it is acceptable, but as you can see, I don't like this morphology at all because it is a little bit too much inside the left atrium. So once I have rotated the left atrium and seen in a few seconds the predictions of the company, I have made my idea of implanting a 27. So this is the 27, and this is the confrontation, just a quick look at how the undeformed device appears in this appendage, so to have an idea of the degree of compression. Then the rotation of the whole system with the device inside permits you to see clearly the interaction of this device, let's say in this case with the mitral annulus. So you see we have a safe distance of the device from the mitral annulus, and then you can play again with the device. The color code you see is the apposition color code, and as you can read here, 0 millimeter is yellow, means that you are touching the left atrial wall, and 2 millimeter is red, you are 2 millimeter far from the atrial wall. So playing and rotating, as you have seen all around the device, you can clearly have an idea if the device is touching all the landing zone of the appendage. The other thing you see here in this frame picture very clearly is the interaction that does not exist of the Watchman Flex 27 with the ostium of the pulmonary vein. So you can say that this device is not impinging the mitral, is not touching and impinging the left pulmonary vein, and has a good apposition and a good frame deformation. And I think going in the cath lab, doing a procedure that is not in my hands, in our cath lab, the most experienced procedure with a nice monitoring without our usual transesophageal monitoring gives you a comfort of concentrating on the maneuvers and on the safety of everything without having the problem of where positioning the device, which device to choose, because you can be quite sure you have to position a 27 millimeter flex a little bit deep inside this appendage. This is the video. These are the videos of the maneuver. So you have seen the transeptal, and you see very nice monitoring of the transeptal puncture of this procedure by eyes. This is the way I cross the septum with the eyes probe. So doing a little bit of hole going back and forth with the introducer of the flex device. I generally put 2 wires, and in the RAO projection, I direct the the probe of ice in the middle of the 2 wires, crossing the septum. And this is the image of this appendage by ice. You can see that is an imaging that, in my opinion, is enough to say that there is not a thrombus and to follow the implantation, but I would not trust on this image to sides again the appendage. So to be sure, we did an angio because the patient had not renal failure, so we did the common 2 angiography, RIO and RIO caudal, and we did again a measure that was around 19. So again, you can have an uncertainty about the sizing, but we stayed on what was our prediction by the software, by FEops company. So we selected the 27 device, and as you can see here, the maneuver with the flex device is quite easy because you have this ball morphology. Probably you are aware of it. This is a big news for the Watchman users from the previous device. So you have the ball morphology that permits you to go inside the appendage as far as you need. And we said that we needed a depth and an implant depth quite meaningful. So we went inside the appendage, and you see clearly the ball also by the ice probe. And this is the opening of the device by the unsheathing maneuver. So once you reach the distal position, you have only to unsheath very easily this device. And as you can see, the maneuver is quite smooth and easy. I mean, the device is not jumping anywhere, stays where you predicted it has to stay, and you are very relaxed in terms of repositioning or recapturing. It is not a hard maneuver. Let's say like this, it's a smooth maneuver. And this is my angiography before the release of the device. And this is how ICE permits you to monitor the position in relation to the circumflex artery and in this projection to the mitral valve. The device was released because we was satisfied by angio and by echo, and this is the final image with a nice embolization of the appendage. And this is very interesting to me because the prediction of FEops was a compression of around 22 millimeter, and this is exactly what we measured on the angiography, and also the morphology is quite the same. So this case was nice for many reasons, but was very facilitated in my hands because we had not to think very much of the sizing, the positioning. We were quite sure of what we were going to do, and we could concentrate on the other maneuvers. And this is, if you don't have any question, I can proceed to my second case.
Yes, Francesco, there are a couple of questions coming on the chat line. The first one is it possible with the FEops HEARTguide solutions to simulate the delivery sheet positions? In other words, from the transeptal puncture towards the LEA. Well, that's the first question. And I don't know if you want to comment on that, Francesco. Or
yes, Christian, if you remember, we are discussing this,
absolutely,
this
yes.
argument in many of our meetings. This is a very important question.
Yes.
And thank you for the question, because this is the other point. When you try to simulate, you reach it as a company, in my opinion, a very good level of prediction, as we have seen, and we will see in other cases, of prediction of device positioning and sizing. The thing that is to be done yet is the simulation of the trajectory of the transeptal puncture and of the trajectory of the delivery system. That could be a tricky part of the procedure at all. So yes, this is my answer.
But and the very good news is that we were very actively listening to your comments, and not only you, because many other people make exactly the same comments, which makes a lot of sense. Of course, if you can reach easily the LEA from the transeptal puncture. Of course, the rest of the intervention is also probably more easier. So the good news is that next week we launch a new release of the FEops HEARTguide, and this new release, we will have the shape of the fossa ovalis real, and we will also show you what could be potentially the best location for puncturing, and we will show you an idea about the trajectory from the fossa ovalis to the LEA as well. So this will be there online as of next week. So concretely,
this is a great news also for me. Thank you, Christian.
Yeah. So okay, so this is the first question. There are also many other questions. So one of the questions we received from one person, the comments, it's more comments like the CT in general for analysis does not necessarily reflect the current status during the implantation. In other words, LEA pressure can be different. The space around the anatomy, what we call the separation, can be different. And the question is mainly, is the simulation taking all those things into consideration for the intervention? In other words, how can we trust that the CT analysis is reflecting the real state of the heart at the moment of the operation?
So thank you. This is, again, a very good question. It comes from an experienced operator. And,
I guess.
And I don't know the name, but for sure, the question is a very good one. And my answer is that for sure, measures can change in the cath lab from what you measure on the CT scan, let's say 2-3 days or 15 days before, because of the loading condition on the pressure of the left atrial side. So you have to measure in the cath lab with a reasonable left atrial pressure, let's say above 5 or 10 millimeters is better. And the beauty of this combination of the simulation device and the simulation software and a device that has a wide overlap of choice of measures is that if you change your idea in the last minute because you see a bigger or a smaller appendage than you predicted, maybe you can use the same device, because this device could be deformated, as you have seen, from 10 to 30%, and this is again, as I say, very is a step forward in the way we leave the procedure. It is a more relaxed choice, and I think the prediction is real in the sense that you are very well oriented once you go there, and you change your mind if you see significant difference, let's say with the echo measures, but you still can rely on, as I showed you in this case, on what you have measured on the CT scan, because let's say in this case, we had a measure of 18 millimeter on the angiography, so a little bit smaller landing zone that the one measured by CT scan, but at the end, the 27 was fitting very well in the appendage due to the characteristic of this device that is very soft and is like a self-expanding stent, if you understand what I mean.
Yes. Thank you. Those are the questions so far, and the physician just said thank you for the answer. Okay. We need to move on. Thank you.
Okay. So I think we have time for another case, and this is an interesting case of a 77-year-old lady with a previous history of mitral surgery, 2 times with a mitral valvuloplasty, surgical mitral valvuloplasty, then a bioprosthesis in 2013, then congestive heart failure, a silent AFib, and 2 episodes of cerebral hemorrhage. So she underwent she was proposed for a left atrial appendage occlusion, and this was the CT scan with a huge appendage, 30-31 millimeter of measures, and we did this procedure with the Amulet 34 device, and this is the procedure. This was monitored, as you can see, with the transesophageal echocardiography, and these are the angiographies with the same 2 projection we do in our standard practice. And this is the positioning of the lobe of this device. If you are experienced also with this device, it's the lobe with the ball-shaped morphology, and then the disc that has to be positioned outside the appendage. And as you can see from this steel frame, the distance between lobe and disc was good. The deformation of the lobe was good. What was not good is this moving image. This is the interference of the disc that is well positioned outside the appendage with the mitral prosthesis. So we had something wrong in the disc that was too much, that was a little bit too big for this anatomy and was impinging the mitral valve. So I tried, to be sincere, to position differently the device and also the disc by pushing everything inside, recapturing the device and placing it again. And this was the morphology that could be acceptable because it was not interfering with the mitral valve, but I didn't trust this morphology because I thought that the nitinol could regain its natural position a few minutes or a few hours later and have problems on the mitral valve. So I decided to remove the device and let the patient without any device because we didn't have the flex device yet in our cath lab. We decided to try again this procedure with a flex device. Of course, we couldn't admit a second failure, so we decided to send images to FEops. This is the prediction from the sizing chart, and this is for sure a big device, so 31 or better, a 35 millimeter Watchman flex, and this is what FEops gave us in return. And as you can see, a big appendage, again a scrolling maneuver, again the implant projection, and you will see in a minute what was most interesting is the mitral. So we uploaded the mitral annulus on this simulation and rotated the atrium as we liked it, just to see better the disposition of the device versus the mitral. And as you will see in a moment, the device, the simulation is done with the 31 and with the 35. The device is, the 31 is for sure too small. As you can see, there is too much red in this picture. The good color is yellow. And then the 35, you will see in a moment, is, let's say, yellow enough and with good distance from the mitral, as you see. This is the beauty of this simulation, that you can rotate as much as you want just to have an idea of what will happen in terms of mitral impinging. This is the other simulation just to see if there is any problem with the pulmonary veins, and at the end we decided that we could try. Although this is yes, because the other measure, it is the device compression, 14%, that is good enough to be a choice for the case. So we went in the cath lab again, and we tried to implant the 35 device. You can see the maneuver. So the device is placed distally with a little bit of counterclockwise rotation of the delivery sheet, and you see the morphology of the ball is a little bit deformated. So it means you are touching the wall. From this point, you have only to unsheath the device, and this is the unsheathing maneuver, and the positioning. You have to do a little bit of pushing once you have unsheathed the device. You push it, then you measure the compression, 27. You can do, as you see here, a gentle tug test. That means the device is stable enough. There is no leak at color Doppler. And most of all important, there is no interference with the mitral valve. So the prediction was good, the position was good, and this is the angiography, very satisfactory in terms of absence of flow in the appendage. This is the release of the device, and as before, the little picture of the device deformation and the prediction of FEops. And this is the last case, sorry, the last slide of my second case. So I think if you have a few questions, we have a few more minutes. Christian?
Yeah, there are, sorry, Francesco, there are no more questions for the timing. I propose that we go for the quick poll first, and then we can come to additional questions afterwards.
Okay. So if you want to answer this poll, after this session, let's say these two cases, I have another wonderful case, but it will be another time. After this session, would you consider to use computer simulation associated to CT scan if you had the opportunity, for sure? Yes, no, or only for specific cases? Please answer, and then we will see if there is something new for you in this technology or not. Oh, there are. I cannot see your answer yet, but I think
this is coming.
Okay. Okay, thank you for the as you can read, 75% said yes, 38 only for specific cases, but nobody said no. So Christian, I think this is a clear message for you. Well, this is a good answer because everybody's thinking that or in specific cases or in any procedure, you can have some insight with the simulation FEops system. And this is also my thought, my way of thinking. I think this is kind of obligated step after a CT scan. It will be something like that. I mean, nowadays it's something new, but could be in the future. We will send a CT scan and we will have back an answer like the one we said today, we solved today, that is a more complete and more easy way of reading the CT scan.
So thank you so much. Of course, I'm very happy with this. I was not, didn't know exactly what we could expect. So first of all, it looks like, first of all, FEops HEARTguide is a tool convincing the physician, but you were also very convincing with your practice based on your personal experience. I just have a small question before we can finally conclude on this call. I also see a few physicians saying that it will be also applicable for specific cases. According to your experiences, when did you saw the best benefit of using FEops HEARTguide for typical different type of LEA morphologies, or can you give us a bit more ideas about your personal experience on that?
I think one of the most important insight is when you have to face a big appendage and you can have problems with surrounding structures. So the simulation of where you will land and what you can do at the surrounding structure, most of all the mitral valve, is paramount. Then there are also tricky appendages like the one with a chicken wing morphology, where you can play very much before going in the cath lab and choose the position and the right device.
Okay, and the very last questions coming from the audience now is during the procedures, do you compare echo sizing versus the CT tools, or it's only with CT scan? And probably I can help you with this question. Of course, based on your experience today, FEops HEARTguide is only based on CT scan. So meaning that's clear. We also follow those type of recommendations there, but we are also considering now in the next development, the future development, also to try to make some evaluation with the echo images as well. So that's in a nutshell the actual situation. Any other comments on that, Francesco, based on your experience? Is a CT a good decision from FEops HEARTguide to focus on for the moment?
Yes, for sure. I am 100% enthusiastic on CT scan planning on LEA procedure.
Okay.
So.
Okay, just to respect all the audience and your time, I would like to conclude here. I just want to address the magical world in all the languages of the world. Thank you so much. Thank you for the audience for being with us. Thank you also for Boston Scientific for their collaboration with this project. And thank you, Francesco Meucci, for this very exciting and very nice presentation. For all, I wish you a very nice PCR 2021. Thank you and see you in the future. Bye.
Ciao.
Ciao.